Hello. Yeah, welcome to session number 3 in the series Multimedia Processing. Just a brief recap of what we did last time. We had a bunch of images, some of them black and white, some of them colored. So what we did was we opened a file in a binary mode and read the header of the BMP to get the information about a BMP. So that's what we did. So there are a few functions which we have written for that, and we are going to have a brief overview of what we did. So this function was written to extract the header. So the header information is there in two structures here. One is the file information, other is the image information. The file information, so I'm just going to run this function so to fill in this structure. So these two structures are basically, if I go to the main file where I calling, so to this I'm going to pass the path of the image. So image in this case is Lena, right? And that's basically this image, right? And I'm going to pass that path, and then I'm going to I created these two structures, and I'm going to pass these two structures using pointers to this function. And then there is a boolean which says, do I want to echo the information? So the information will be retrieved in these two structures, which are defined in this data structs header file over here, right? And that's what we are going to do. So let's go ahead and build the solution, and let's just run it. So it says that this is the file lena.bmp. It has a signature called bm here at the top. Then this is the file size, which will be 54 plus width into height. So this is 512 is the width and height is 512. So 512 into 512 is 786432 plus 54 will be 786486, right? So you can tally the sizes here. Then it says that the data offset is at 54. So basically this header information is stored in 54 bytes here, right? And from there onwards the data starts, right? So again there is this resolution of x and y, which is of not much consequence right now, but if we do some processing and to the scale images, we will be able to figure out the sizes of various components of an image, right? So that's the idea. So this information is extracted by this function which I have written in image stat. So this is the header file. So this is the declaration of the where is it? Image read. So this is the declaration of the there is image dot header. Yeah, so this is the declaration of the function, and the corresponding C file is over here where the function is over here. So I'm just opening it and I'm just reading byte by byte or integer, and then I'm printing it out. So if echo is true, this information is printed out. So this is what we did earlier. Then we also took the image, and if it was a colored image, we split it up into blue, green and red. So that is the sequence of the data. So if I just build the solution, and so to this function I'm passing the input file, which is Lena wpath, and then the output file are three of them, red, green and blue, which are three paths are passed here. So the prototype of the function is there in image write. Okay, so that is split colors, and that's the function, right? So I'm opening one file in read mode and three files in write mode, and then I'm reading the file, and then I'm separating out the red, green, the blue, green and the red. So here, yeah, so blue, green and red, that's what we are doing. Okay, so that's the function, and its prototype is there in image write.h. So that's the prototype here, right? So I am including this header file in my main program over here, and that means that I can call these functions. So if I go ahead and call this function, okay, let's see the result. So it is done, and it exited with code 0, means that nothing went wrong. So if I go to processed folder, I'll find blue, green and red, right? So this is what we did last time. Now there are three planes to a image. right? So you can consider this as a width cross height cross 3 as the size of the matrix. And so that's what we did. We just separated out the three this thing. Now black and white images also have 24-bit black and white images. Like over here, this is a 24-bit black and white image. Okay, now this also has got 3 planes, but all the pixel values are the same. Similarly for here, the moon.bmp is the same, chest.xray is the same 24-bit information. So let's just see, let's say moon.bmp, let's see its header information, right? So go here and just build this solution and debug it. So it says moon, okay, we haven't changed the path, so let's first change the path here. It is called moon.bmp. Build it, and once it's built, you just run it without debugging, and you'll find that moon.bmp has got this size. Header offset is still 54. The image width and height is this, and number of planes in the image is 1, and bits per pixel is still 24. So even if it is a black and white image, there are 3 planes, okay, and each plane is a pixel is represented by 1 byte, so there are 3 bytes per pixel, so that's 24 bits per pixel, right? So the only thing in black and white images that all the pixel values in blue, green, red are the same. That's why it looks gray colored. So I wrote a program which is called is black and white. So this is under stats, okay, image stats. This is the function declaration, and this is the actual function in the C file. So all I'm doing is I'm checking with red, blue, or green they are same, and if they are same, then I'm just passing back a boolean which says it's true, or it returns 1, right? So for doing boolean, you have to include this stdbool.h, right? So now let's run this. We have already run this, and it says image is black and white, so it says 1. It means it's true. Now if I change the image to something else, let's say Audrey, AURDY, I spelled it wrong, but that's how it is spelled in the image here. It is called Audrey. Okay, so this is a colored image, so we will come to know whether it's a colored image or not. So if it's a colored image, it will return 0. So I'll just build this, and I will go here and debug it. And what do I find? Is image is black and white, 0. That means it is not black and white, it is colored, right? So that's what is happening. Then I also wrote a program to convert the colored image into black and white. So all I'm passing to this function is 2 paths. One is the input file, other is the output file, and that is going to go to RGB to gray, and RGB to gray is under image write. There is a function called RGB to gray which I have written, and all it is doing is it is taking the 3 pixels and averaging them out, right? So it is reading 3 pixels and averaging them out and placing this in the output file as same pixel values, which are these average of the 3 colors, right? So when I do that, and if I build solution and I run this, okay, so it is Audrey. It's not a black and white image, but then I have generated a grayscale of this. So if I look into the output folder, I'll find that I'll have blue, green, red, and then I have a gray, right? So this was just the average of the 3 colors, and then 3 planes are having same pixel values, so that's why it shows up as a black and white image, right, or a grayscale image. So having done that, there was another thing which I did. Let me just delete the output files. Okay, so another thing which I did was I did the reverse of it. So let's go back and see what is the reverse. The reverse is gray to RGB. So I'll take a grayscale image, and here I have to do a little bit of explanation what is going on here. So let me just show you what goes on there, right? Okay, so what's going on here is the following. I take the scale which goes from 0 to 255, right? Right, so this is a black and white image. That means that all the three planes are having same pixel values. Then what I did was I divided it into three regions, right? And each region, okay, so each region I expanded to the same 0 to 255, and this I placed as a blue color. Then I took the other range, which was this, and I expanded this again to 0 to 255, and I put it as a green plane, right? And then finally I took the final range, which is over here, and I again stretched it to 0 to 255 and put it as a third plane. So this is how I converted black and white into a pseudo colored image. So let's see how it works. So what I do is, let's go back to the code. Okay, so that's what I did here. I just put them in three bins of blue, green, red, and I stretched them to 0 to 255. So that's all I did that, and that I called as gray to RGB, and the prototype is over here in the header file. Gray to RGB. It receives an input path and an output path. That's it. And when I call it over here, so first it is going to check. So I'm going to disable this. I'm going to disable this one. And first of all, and then I'm going to put here, let's say, chest. Okay. And here, what I did was, I am just checking if it is a black and white image, then I have to apply this pseudo coloring, right? So I have an input path file name and then the output path file name. So I just build this, and I just go here and say start without debugging. So this is the chest is the input file. This is the size of the file. This is the dimensions in pixels. There are 24 bits, means each byte, each plane, the pixel is represented by 1 byte, and there are 3 planes. All planes have same pixel values. That's why it says image is black and white, yes, right? And what it has done is, it has done just what I showed you as an algorithm over here, right? Right. And the results you can see over here. Okay, so it has taken the black and white image, which is over here, and converted into a pseudo color image, right? So it might give you more information. So let's look at a bigger image. So let's see if it gives you a lot of details. So let's go here and put here chest X-ray. I think that's a bigger image. So let's put this as chest X-ray. Okay, so I'm just going to build this, and I'm going to start with the debugging, and it's a slightly bigger file, and it's a black and white image. Okay, doesn't matter. Close this and just go to the output folder and open this. So now here, this is a pseudo colored image of the same chest X-ray, right, which is over here, right? So this is usually for visualization purpose. This has no additional information. It's just that you are able to see more contrast and more colors, so that you can figure out some of the regions of the image, and then you can get more information visually. So that's what we did in the first session. Now in this session we are going to study more about these images by writing programs, right? Okay, so let's look at another image, and that image is over here. you just call CT. And when you look at this image, you say, oh, this one has all dull colors, right? So how do you reach a conclusion that this has dull colors? Can I say that the brightness is less? Well, so now there are two questions here. One question is brightness. The other question is contrast. So brightness has to do with the mean value of various planes, blue, green, red. So if the mean value is less, that means that the brightness is less. When the mean value is high, that means that the brightness is high. So if I take the blue pixels and do a mean of it, right? Or if I take green pixels mean of it and red pixels mean of it, then I would know what is its brightness level. But if I look at the min max of the blue, green and red, then I would know what is the contrast. So you understand the difference between the two. The brightness has to do with the mean or the average value of the pixels, right? Higher it is, brighter the picture. Lower it is, darker the picture. But then the min max values, whether they are stretched over complete range of 0 to 255 or whether they are in a limited range, right? So for example, let's look at this image. This one is a contrast stretched image and it looks very bright, right? And so it's a misnomer when I say bright. It doesn't mean that the average value is high. It just means that the contrast is high. So how do I learn that, right? So for that, let's write a function. Okay, and I'll call that function as min max, right? Okay, so let's look at that. So first of all, I'm going to disable this. I'm not doing this black and white to pseudo coloring here. I'm going to write more information about the file, right? So for that, under image stat, I'm going to write a function, and that function is going to be returning nothing to me because I'll get the return path on the pointers, right? So I can say min max, and what this min max is going to do is it is going to receive a file path which it's going to open. So that is going to be, let's say, f path. Then it is going to receive a pointer to min max values, right? So I can say character, and that pointer is, let's say, b min. Okay, b min, right? And then I can say a character which I pass pointer to that character, that will have g min. Then I have a character that I pass would have r min. So these are the min values which I want to receive back. Right. So we have b min, g min, r min. Similarly, I'm going to just copy this. I want to receive the max values. Right. So I'll just paste this and say b max, g max and r max. So using these pointers, I'm going to return the min max values. Right. Next thing, I want to look at the mean values. Now in mean values, I have to sum the pixel values, right? So when I sum the pixel values, it can become a very large number because depending on the number of pixels, right? So instead of using int char or anything, I'm gonna, so one more thing is there. These characters are going to be all unsigned. Right, so let's make them unsigned characters. Okay, so bear with me. Okay, the next thing I want to receive is the mean value. So to calculate a mean value, what do? I add all the pixels and divide by the number of pixels, right? So in that case, let's pass here unsigned. The biggest number we can think of is a long, so a pointer to that, and let's say this is called b mean, and then I would have unsigned long g mean, sorry, then I am going to have unsigned long and r mean, correct? And then I also want to pass a boolean telling it whether it wants to print, I want to print something, so I'll say boolean, I'll call it as echo, ECH, echo. So that is going to be my function signature. So here I am going to first, when I start this function, I am going to first open the file. So I can say file pointer, and also I need to initialize gmin, bmin, rmin, bmax, gmax, rmax, and the mean value. So I can say the contents of bmin is equal to the maximum value I will put here, and later it will take the minimum value. So this is my starting condition, bmin. Okay, this has become bin, sorry about that, bmin. Okay, then you have got gmin, that's equal to 255. So that's the starting value. I'm assuming that the minimum is 255 to start with. Then rmin. Okay, so this is about the min values, and on the other extreme I will initialize the max values as 0. Sorry about that. So all these max values are 0. Okay, so these are max values. Let me just copy paste this first, and these are max values, right? For some reason it is not taking b max and r max, or b max size. Let's see, this is b max. Okay, now it's okay. And these are the mean values, and the mean values are also initialized to 0, right? Okay, so we are ready to start with. So what's wrong with r mean? r mean. Oh, because I haven't passed the pointer, right? Okay, so now I'm going to open the file. So I will say fp is equal to fopen, and in that I'm going to pass the path to the file, which is given by fpath, and this is going to be the input file. Then I am going to read it in a binary mode, in a read mode, so that will be rb. And first of all I'm going to check whether the pointer is assigned something or it is null. So if it is null, that means it failed to open the file. So if it failed to open the file, I'm going to print a message to myself, is say failed to open input file, right? So this will be a message saying that for some reasons I could not open this file. This can happen if you have a file which is writing or reading from a location where you don't have access. Okay, and if that happens, you just return. Okay, otherwise I'm going to start processing, right? So first of all I need some information about the file, right? So I want to see where the data offset is, so I would say fseek, and if I look at the header, the information offset is usually at the 10th byte in the header, So this is some typical numbers are there. So the offset is at the 10th byte. So here I need to create some more integers. So let's say unsigned int, that will store the offset. Then there will be an integer to store the width. There will be an integer to store the height. Then there will be an integer unsigned. So there will be an integer, or rather long that will store the image size. So there are two ways of getting image size. One is you can get it from the header itself, right? So in the header there is image size here, right? Or you can take the width and the height and multiply it. So that will also give you the image size. So here I am going to read the offset. So I'm going to say fread, and I'm going to pass the pointer to offset, right? And then I am going to put size of integer. That's what it is, and I'm going to read one integer from the file pointed by fp. So this will return me the offset of the data offset, which will usually be 54, right? Then I am going to put the fseek fp, and that the 18th byte is the width information, right? So I'm going to just say fread ampersand width, comma, size of int, and I want to read 1 byte and from the file pointed by fp. So that will give me the width, and then I can read the height. So I'm just going to repeat this statement because it is consecutive in the binary image. So the next one would be the height. Then I'll put back the pointer to the offset. So I'll say offset, so fp comma offset comma 0 from the starting. So now I'm ready to analyze the pixels, right? So I want to get the min and the max, right? So if I do if I read this in an unsigned character, let's say call it ch, right? So I'm going to pass a pointer, so id fread. So now I will be running this for how much? The entire size of this image, right? So let me compute the size here. So I can say im size is equal to w into h. So that's the size of the image. So I will analyze all the pixels. I less than im size and I plus plus. Well, this will be I has to be initialized to 0. For I'm going to analyze all the pixels, right? Now, okay, let's do that. I'm going to do a fread, and I'm going to read the byte in a character, size of character, 1 character from file pointer fp. So I have read the character. Then I'm going to say if the content of b min is greater than character, right, then the content of b min should be equal to character, right? Makes sense, right? So I'm trying to get the minimum value, right? And then if contents of b max is less than character, right, then I'm going to do something, right? So I'm going to say b max is equal to ch. Okay, so these two things I have done to look at the min and the max value, and then I would look at the mean value. So for the mean value, what do? I have assigned them to 0 here. So I would say contents of B mean is equal to contents of B mean plus CH. Correct? So this is going to sum all the blue pixels for the entire image size. So same thing I'm going to repeat here, and I would say the next character red is green, so I will look at G min and I will look at G max, and I will add G mean value to G mean value plus CH. Correct? And the same thing I'm going to repeat for the red one. So I will look at the R min value and the R max value. Right, and I will look at R mean, and I will say R mean equal to R mean plus CH. So at the end I would have the sum of all the blue pixels. So I will say B mean is equal to contents of B mean divided by IM size. So that will basically do the average of all the pixels. So the sum of all the pixels divided by the number of all the pixels, that will give you the average. Similarly, you have got G mean is equal to contents of G mean divided by IM size, and similarly I can copy paste, Control C, Control V, and I say R mean is equal to R mean by image size. Now at the end of this I have got all the information, right? Now I would just close the file, F close and FV. So I'm done with all the information I wanted to gather, right? And now I'm going to echo this. So if there is a boolean ECH, right, then what do I have to do? I have to say printf, okay, formatting string, new line character, min blue % is equal to percentage, this is going to be a number D, then tab value, and then I'm just going to repeat this. So I'm going to print all the mean values, right? Min green, and then I would have min, okay, sorry about that, min blue, green and red, right? And this red I would put it here like this, and I would just say B min, G min and R min. Okay, so this I would have printed. Then I'm going to just repeat this to print the max value. So all I do is max of blue, max of green and max of red, right? So this will be B max, then this will be G max, this will be R max, right? And same thing I'm going to repeat with the mean value, mean blue, mean green, mean red, and this will be printing mean. Okay, so I have printed all the values. Now I have nothing to do here, it is done, right? So this function is written. So all I have to do is create this as a prototype, right? Hang on. Control C, put it in its header file, image.header, Control V, and here you basically don't need the naming, correct? So you don't need this ECH, R mean, G mean, B mean, R max, Gmax. Okay, so I did a mistake here, and Vmax, and you have got, so I'm just in a prototype, I usually don't put the variable names. Okay, and then the F path. So that's the prototype. I'm going to just say save, yes. Okay, so I have written the function and I have written its prototype, and now I have to just call it, right? So if I go to the main file and I would say, so I would just paste this, right? And I'm calling that. So one more thing, I have to pass here the file path. So I'll say this is w path, and here I have to have these to receive the values, right? So I'm going to say unsigned character and say bmin, gmin, rmin, bmax, gmax, rmax, b. Okay, so these will be characters, and then you are going to have signed long as bmean, gmean, and rmean, right? So here I am going to just call this one with bmin, gmin, rmin, bmax, gmax, rmax, bmean, gmean, rmean, and then echo is true. Okay, one more thing is there, I have to pass the pointers, so everyone would be ampersand, right? So if any function is calling, this is how it would have to call it. Okay, so I guess this is how you call it, right? So let's look at chest x-ray. Now this chest x-ray is a black and white image, so let's look at Audrey. Okay, and just say build solution. Okay, printf line something. Requires an argument, hang on, of type int. So of course, you know, these are not the pointers which I need to print. I need to print the contents, right? So I need to print the contents pointed by these pointers which I have passed. So everywhere you will have to do this. You have to look at the content pointed by that pointer. Okay, so we are all set now. Let's say build solution, and it's done, and I'm gonna just say start without debugging. So somehow the tabs are not properly placed. Okay, still I'm gonna just correct it. So here tab has come earlier, here also. So let's look at this. So the tabs have to come after this. Tab. Sorry about that. Tab. Right. So the tabs have to come after that. Sorry for this mess up. It should look clean, right? That's the whole idea. So that's fine. Let's run this again. Debug, start without debugging. Okay. So min values are 0, max values are 255, and blue mean is 99, green mean is 108, and red mean is 150. So you see what it says? There is more of red than blue, because the mean value of red is higher than the blue, so there is more of red than the blue. And if you look at the picture, and it is true that there is more red in this picture than the blue. Now you see that the contrast is stretched over the entire range from 0 to 55, so this is the bright image. But on the other hand, if I was to put here city, right, sorry about that, so that city refers to this image. Okay, and we were confused whether the brightness is not good or whether the contrast is not good. Now we will have our answer. So let's just run this, build solution, and say debug, start without debugging. So now this is city, and look at its min value. Min values is 62, 72, 68, not 0. And the max value is 201, 198, 197. That's also not 255. But look at the mean values. Mean values are 138, 136, 137. What it means is that it has a good brightness, but it has a poor contrast, right? And it's not a black and white image, right? So now you have some of your answers about this image, right? Now depending on the time, okay, I can squeeze in one program. Okay, what if I want to improve this image, right? So let's go about improving this image. Okay, so what would I do? I would stretch the contrast. And how would I stretch the contrast? I'll explain over here. Okay, so let's say I took the blue pixels. Okay, so let's say pixel value is px, it's blue colored, right? And I have got its b min and b max, right? Similarly, I have got green, which has a pixel value px, and you have got g min and g max. And then you have got the red one, pixel value is px, which is between R min and R max. Okay, now I need to contrast stretch it. One is the linear way. I can take this range and I expand, sorry about this, I can take this range and I expand it to 0 to 255. I stretch it out. Okay, I can do it for all the colors. There's another thing which is called power law correction. Power law correction. So what I'm going to do is I'm going to take the pixel value, whether it's blue, green, red, doesn't matter, and to this I will raise to certain power, right? So if I do a square, that's what there. Now before I do this, I would do the following. Because I want the entire range, I would do px minus, or in this case let's put the color here. Okay, so let's say we are talking about blue, so px minus b min. So I'm sure that this is going to be equal to 0 for the minimum value of the pixel, right? then I am going to raise it to the power. The power is going to be, let's say, square. Then I will take that range, okay, b min minus b max, okay, and I will scale it. So I will take this b max minus b min, okay, square. So this will be the square of the maximum deviation, b max minus b min, and then I will scale this to 255. So let's say if px was b min, then the answer is 0, right? And if the px was, okay, some value, largest value, which is a b max, so it will be b max minus b min square divided by b max minus b min square. That will become 255. So I have stretched the image from 0 to 255 by a square law. So I can do this by any law, right? I can make it a cube, right? So let's see, write this program and see what happens, right? Okay, so let's go ahead and do that. That is called power law correction. You can do a simple linear also. So in this case, you can put this power as 1. In that case, what will happen? P max minus px minus b min divided by b max minus b min into 255. So I am still stretching from 0 to 255, right? So I'm sorry about typing mistake. 0 to 255, but with the linear correction. So let's write in this image right, let's write a function, and we say void, and this is going to be power law, right? And I'm going to receive two paths. One is for the input image and one is for the output image, right? And then I'm going to receive a double, which is going to be power, right? That's all I need for this function. Okay, so in this case I have that image stat over here, so I can call min max to do that, so to find out the min max. So to cut short this session, I'm going to go here, and this is what I need to do, right, to call that function. So I'll copy that, I'll write it over here. Okay, so this is, I have created that, and then I'm going to call this function as I have called over here. But this time just the echo part I'm going to put as false. So this echo part I'm going to put as false. So I'm passing the input file and calling this function. So from here, so that means that I don't have to call it from here. So that was only for the demo purpose. So I am going to just comment this out. Oh, I already had that. Okay, so let's just comment that out. Okay, so I commented that out, and I'm not calling that function here. So this city is something which we have to improve on, right? So we got the min max values. Now what to do? I'm going to open the files. So I'm going to have file pointer, two file pointers, one for reading, one for writing. Okay, then I'm going to have because you do square, right? 255 square will be inside integer. You can say unsigned int say blue, green, and red, right? So here I'm going to apply the square law, but to use power I will say POX rather, because there is a function called POW, right? Okay, so I've included math.h to do the raise to. Okay, so I'm also going to read unsigned character ch. Okay, so we have to do the same thing as we did in the min max, right? So what we do, we are going to first open the file. So I'll say fp fopen and the path and the mode, read and binary. Now if I fail, so fp will be equal to null. That means that I have to print myself a message, printf fail to open input file, right? So that's going to print that, and then I will say return. Okay, so I have issued myself a warning. Else I was successful in opening the file. Now I can do one thing, I can just get the values, right? So basically I can get the offset first. So I need to create here offset, and then I need to create width and height, and then I will do a unsigned long, and I'll call this as IM size. That's it. Okay, so if else, what do I need to do? I need to seek the offset. Okay, so this is how I'm going to read the 10th byte, right? And here I am going to read the 10th byte in offset, right? Right, so here I have read the offset. Then I am going to place the pointer fp to 18th byte, which is the width, and I'm going to say fread width size of integer 1 from fp, and then consecutively I can get the height if I read the next integer as that, and then I can say image size, right? So I can say IM z w into h. Done. And then I will put back the file pointer fp back to the start, right? Okay, now next thing I'm going to do is I am going to open the write file. So I have another pointer, it says fopen, and I am going to pass the path. Okay, so that will be called wpath, and I will open this in a binary write mode, right? And first thing first is if I fail to do that, then fw would be null, and if fw is null, I have to write myself a message, printf fail to open output file, right? And return. Now before return, I know that one file pointer is open, so I will say fclose fp. So I don't want to leave any file pointers open, so that would be handling the failure to open the write file. Else now I'm ready to do the processing. So my read pointer is at 0 0, so I am going to just say for unsigned int I equal to 0, I less than offset. So up to offset I'm going to copy the things as is, which is the header. So I'm going to say fread, and I'm going to read a character size of a character fp, and then I am going to write this f write the same character. So I'm just copying the header of the file. Size of character fw. Okay, so I have read the characters and I have written the characters. So at the end of it, when I reach, I am ready to look at the image, right? So for unsigned int I equal to 0, I less than im size I plus plus. So for the entire length of the file, I'm going to read the blue pixel. Let's say, for example, f read, and I would say I want to read this. Now this thing is going to be a character. Size of a character 1 fp. So this will be my blue data, right? And I would say blue is going to be equal to, okay, character minus b min. Okay, so this is there. This has to be raised to a power of, this has to be raised to a power of 2, let's say, or pox. So this has to be raised to this power, p o w. Okay, so that's there. Now I have to scale this. Now every time if I do maths, that would be wrong, right? Because once I have the mean values, I already know what should be the scaling factor, isn't it? Right? So I would put here unsigned int b new value, b scale, g scale, and r scale, because I don't want to compute this again and again, right? So once I call this function, okay, I can say b scale would be equal to 255 divided by, now that will be 0 all the time if this b scale is not double, right? Okay, so let's not do that. Let it do the maths, or you have to do the casting. Okay, so I don't want to complicate for you. I want to keep it simple. Let it take more time to process. Okay, so over here I can say this divided by something, which is going to be power of b max minus b min. It seems so unright to do this. Okay, another way I can do is I can still put here unsigned int, okay, b s, okay, that's okay, b s g s r s. Okay, and then what I'm going to do is, once I have read this, I will say bs is equal to power of b max minus b min. Okay, so this one comma pox. Okay, so this is your bs. Then I'm going to do gs. gs will be g max minus g min to the power. Then I will do a rs, will be r max, r min, and that. Okay, so now here I want to do the multiplication first. Okay, which anyways will happen, but I want to be sure I multiply first, and then I will do the division, which will be BS. Okay, so I did that. Okay, so I applied this. Okay, right, so to me it looks okay. Then I will read so I will just cast to unsigned character the value which I got, which is going to be blue. Right, so this is a contrast stretch value. Then I'm going to write this f write ch comma size of character 1 comma fb. So I have written the contrast stretched blue value. Then I am going to write for the green. So I did a f read, and I'll say green is equal to ch minus gmin raised to this by gs. So that's the contrast stretch green value, and I am going to cast it to a character and write it. And same thing I'm going to repeat with the red value. Contrast stretched, and this will be rs, and I'll be writing the red value as the character. So let me just make sure I have got blue, green, red is integer, and BS, GS, RS is integers. And once I've called it, I did the power of this, right? And I'm calling and doing the power of that with 255 by BS, 255 by GS, and 255 by RS. Yeah, so this seems complete. So once I have done for all the pixels, what am I going to do? I am going to do a f close the read file. Okay, and then I'm going to do a f flush. So this means if there is something in the buffer for fw, write it before you close it. And I'm going to say close fw. Okay, so now this function is ready to contrast stretch the image by a power law. So that's the power law, correct? Okay, so let's make a prototype of this. Control C, put it in the image right header. Control V, and I don't need the names, which is fine. And here I am going to call this function. So I am going to create the output file path. So I'm going to say copy this, Control V. So I will call this as POW path, and this is a power law. Make sense? Now there is a issue. The issue is here is, shouldn't it be a double? Okay, so let's fix the issue first. Okay, that will be an image, right? So can I not declare these as double? Okay, this is because if you raise something to, let's say, half, then the number would have decimals, right? So for example, if I raised, and what about this? This should also be a double, isn't it? Right, so these are all double. But anyways, POV is going to intrinsically cast it, but to be sure, POW is in the math.h is going to cast that. So anyways, so this is double and these are double. So then this is a double and these are double, and then the double is cast to an integer unsigned car. Okay, so now it makes sense. Okay, so you have to do it correctly, right? So here I am going to write it in this path. So let's call that method. So the method is here called power law, isn't it? Control C, Control V, and to this I'm going to pass the original file, and then I'm going to pass the POW path, and this one, let's say, is a square to start with. Later we will do different values. Why a square? Why not just 1.5? How's that? 1.5. Okay, so what I'm expecting is that this will do its job. So I'll say build solution. So I haven't goofed up, at least till now. So it's reading this file and says stream null pointer abort stream null pointer. Let's check this. Okay, so I'm having FPFW read mode. That's there. So I'm reading FP, I'm reading the values, right? FPFW, FP, F write has to be FW. How can I open to a read only file, right? So that's my mistake here. That's the problem. FW, FW. Okay, now it's okay. So such things you should know. Okay, let me just free this. Okay, let's run this again. So this still somewhere I'm doing a mistake. Reading it, write binary, reading FW, writing to FW, F flush. Okay, so let me put you on a pause for now. Let me just figure out what happened. Okay, sometimes we do some stupid stuff. Like for example, sometime back I was doing this and I was getting an error and I had to debug it. So this is a equality. This is not a equality. This is a comparison. So that's why there has to be a double equal to. Okay, so now everything looks okay. Okay, so this is the original program, and this has a prototype in here, and this has been called from here. Okay, so let's just build this solution and let's just run it. Okay, so this is not a black and white image, and mind you, the original image is over here, this one, correct? And let's see what this power law correction would do. So let's go back to, so it has done it, right? So it has exited with code 0. So let's go to process folder and let's open this one. Okay, so now what do you see? You see the original image, which is over here, and this has been contrast stretched to this. Now you can see that the reds are more red, the greens are more green, the blues are more blue, right? So this would be called power law correction. You can experiment some more with this. you can just go in here and put a stretching of 1. So this is going to be a contrast stretched image without, without squaring. So I'm going to just delete this from the output folder, right? And I'm going to just build solution, and I'm going to debug, start without debugging. Exited with code 0. That means that's done. Let's go back to the output folder. So even stretching with 1 is going to put in more colors, right, compared to what you are seeing here as the input, right? So this is power law correction. Now I can apply higher ratios also, but let's look at any other image as an example. Let's say poor contrast image, this one. Okay, so this is called CT2. Again, this is a poor contrast, so let's look at the contrast enhancement. So I will say CT2, right? So that's the one which I'm going to work on, and I'm going to give here a square, right? And I'm going to remove the output file, though you don't have to, it will overwrite anyways. So let's build solution, and let's just debug it. Done. Let's look at the output. Okay, so that image now versus the input, which is this image. Now notice one thing, I'll show you. Okay, so this is contrast stretched, and this one is fine. So now what's the problem here? The problem here is that the brightness is less here, right? Because everything looks dark, right? So before I even apply the contrast stretching, I can improve the brightness of the image, right? Before. Now if you do after, if you remember, we have already scaled to 0 to 255. If you do a brightness improvement after, then the higher pixel values are going to cross to 55, right? So do it before and then contrast stretch it out. Okay, so anyway, so you can see the difference between the input image and the output image. So this is a contrast stretching through power law. We also applied a contrast stretching of 1. Now we can also do a contrast stretching about mean, so we will write a separate program for that. But for now, I'm going to stop here for this session. Thanks a lot. Thank you.